How do we find the sides of triangles, of a right triangle? What's the relationship between your three sides? The Pythagorean theorem. So let's just find other sides when we have two sides, okay? And also, just like, what did we use on our bell work this morning? Trig functions, right? And those give us ratios of the sides. And we can also use them to find angles. But the problem with both the trig functions and your Pythagorean theorem is that they are dependent upon the right angle. So basically, once we start dealing with oblique triangles, those all go out the door. Okay? We can no longer use them. So we have to have other formulas and things to be able to solve for stuff. Okay? Now, we do have to have enough information in a triangle to be able to solve for anything else. Sometimes we might be solving for another angle, sometimes we might be solving for other sides, but we have to at least be given three things in that triangle to be able to solve for other stuff. Yes? And some of these might sound familiar because you use these kind of in some of your congruency properties in geometry. Yes? Do you remember those? Okay. So today we are covering the law of sines, which is the top half of your handout, and those are going to cover these first two cases. And basically the law of sines is just a formula. It's a formula that we're going to be able to use to solve for sides or angles when we are given either angle, angle, side, okay, or angle, side, angle. So in the little bubble next to where it says cases, on those first two blanks, you're going to put angle, angle, side, and angle, side, angle. And those are the two cases that we're going to cover today. Now, the ambiguous case, which is the next blank, is what we're going to cover tomorrow, and that is side, side, angle. And we're all big kids in here, so we're all going to be appropriate and put it as side, side, angle, and not the other way around. Yes?
That is a great picture of my geometry teacher, like writing it on the board in my own cabinet.
So, and the reason why you probably didn't cover that case is because it does lead to some different issues as far as like, we're going to have to look at a couple different things with that tomorrow. Yes? So now, looking at those three triangles at the bottom where it asks us to classify, looks something like this. Okay? We need to be able to identify which case we have when. So like on this first one, what are we given? Angle, side, angle. What are we given on the second one?
Angle, angle, side.
And what are we given on the last one? Start with the side. Agreed. Okay? Remember that it doesn't matter where you start, but you have to do them in order after that. So this could also read side, angle, angle, and that would be okay. But notice that these do not have the same number of tick marks, which means that they are not necessarily equal to one another. It's just those are the things that we are going to be given, and then we can either solve for one of the other sides or one of the other angles, depending upon what they ask us to find. Now, when we're doing our homework, most of them are just going to say solve the triangle, which means that you're looking for both of the other sides and the other angle. You're just finding all three of them. Yes? But, getting on to the next part, we have to have a formula that allows us to do that, which is our law of sines. So underneath where it says formula, you want to write down your law of sines. So, generally the way that it works is that our lowercase letters represent sides, our uppercase letters represent angles. If they are corresponding, like little a and big A, that means that they are opposite of one another. Now, notice that on the one that we have written here, all of our sides are on top, and that's usually helpful when we are solving for a side. Sometimes, though, we will solve for an angle, and in that case, it is helpful to take the reciprocal of all three, and we'll use it that way instead. So it might be helpful to put both of those. They're the same formulas, it's just we flip them off because we want the angle to be on top. 3 ratios, but whenever we're solving things, we're just going to create an equation. So we're going to pick 2 of the ratios that we want to use. So basically, this is just telling us that all 3 of them are equivalent, so we can choose any 2 that we need to use, because they are all equal. Questions so far? Now, a lot of this is just kind of plugging and chugging. Once we have our formulas down, it's basically just putting stuff places and solving, and that's all it's going to be. You might want to have a calculator, because we are going to have to use our calculator. Again, these are oblique triangles, so we're not going to get nice, pretty answers in this case. We're going to have, cosines of 43, sines of 27, okay? They're not going to give us nice, pretty answers, and that's okay. The other nice thing that most of you will probably be happy about is this is the one section, or one unit, that we will mostly be in degrees. Okay, so let's look at an example. So now, on the back side, like I said, we're looking at our first 2 cases today. The first one, just like it says up there on example 1, is an angle, angle, side. So, and underneath your example square, you're going to put the 3 things that are given here. So that's just kind of to show you, or to remind you of what it looks like when you're given 2 angles and a side that is not in between them. So basically, it's going to be one of your 2 letters. Now, on both angle, angle, side, and angle, side, angle, our steps are pretty similar. We're just using law of sines, and under that, where it says steps, we can fill in what those steps look like. Now, notice on both our angle, angle, side, and our angle, side, angle, we are given what? What do those have in common? We have 2 angles. So if I have 2 angles inside of a triangle, what could we easily solve for first? Yeah, so our first step is going to be to solve for the third angle. Yes? Cool. So after that, depending upon what it asks you for, you're going to solve for the remaining sides. Or if it just asks you to solve for one of them, then you just have to find one of them. But we do want to use the givens when possible. Meaning that they give us 3 things, okay? Once we solve for another side, okay, we can technically use that side as well. However, most of the time, like we said, we're not going to get nice, pretty answers. So we will have to round that answer, yes? So then if we use that to find something else, we're going to make our rounding error even bigger. So we want to always go back to our original stuff, or the given stuff, whenever we can. So, how do I find my first missing side? So we're looking for angle A. What do we know about the angles on a triangle? Huh? Yeah, well, the equal what equals 180? All the angles what? Doing what with them?
The sum of them.
The sum of them, adding them all together, right? They don't equal 180. Their sum equals 180. So if I add all my angles together, then I get 180, which also means that if I have my two other angles, we can subtract those. From 180, and it will give me my third. So in this case, we have 180 degrees, that's degrees, minus 29 degrees, minus 102. And what do we get if we subtract those?
49.
Alright. So then from there, okay, it's usually helpful to solve for the biggest side first. Okay, so how do we know which one's our biggest side? Yep, it has to be across from the, well, we don't have a hypotenuse because we don't have a right triangle. But it has to be across from the largest angle. So in this case, which is going to be our largest side? C. Okay, so since I'm looking for C, I have to use the ratio that has C in it. So we start with C, little c, over sine of big C. Yes? And then we're going to set that equal to, well, I have to have the complete fraction on the other side in order to be able to solve. So, which one of those do I have the complete fraction for? A or B? Do I have side A though? Yeah, the only one that we have both the side and the angle for is B. So we have to use that one. Okay. So then we're, again, like I said, once we have our formula, we're basically just plugging and chugging. I'm going to plug in my big C, which is 102 degrees. We have that little b is 28, and big B is 29 degrees. And then we're just solving. Right now we have C divided by sine of 102. So how do we get rid of division? Multiplication. So we're just going to multiply both sides by sine of 102 degrees. And then we're just going to plug all of that in to our handy dandy calculator. You want to make sure you're in degrees, and you want to make sure that when after you type 102, you need to end your parentheses and then click times before you start your division part. Because otherwise it's going to put all of that inside of the sign, and you don't like that. You just want the 102 there. So what do we get when we do that? Okay, we are rounding, so we're going to put approximately, so 56.493, and then we are in feet. Yes? So then it tells us to solve for everything, so what's the last side that we have to solve for? A. So this time we have to use our A fraction. And this is where I told you that technically we have what little c is now. Yes, we could use this fraction and still solve. But do we want to use that one? No, because I had to round to get this answer. So if I use this answer that we rounded to then find something else, we're making our rounding error even bigger. Now, there will be some times, and we'll look at something like that, where we have to use something that we found because we don't have enough information to find everything. But if we do, like in this case, we can still use our little b divided by sine of b. We're going to use that. So here we have sine of A, we found to be 49 degrees. And then our b is still 28 over sine of 29. So again, solving the same way, we're going to multiply both sides by the sine of 49. Plug it on to our hand candy calculator, and what do we get?
43.4
43.588, and we are in feet. So we solved for both sides and the missing angle like it asked us. Yes? What questions do we have? There. Now, this unit is one of my favorite units because we get to do the best part of math. We get to look at application problems. So when we're dealing with trig stuff, right, there's lots of application problems, and that's what your project is going to be over, is you creating your own application problem. But for right now, we're going to look at this one. This is a pole tilts towards the sun at an 8-degree angle from the vertical, and it casts a 22-foot shadow. The angle of elevation from the tip of the shadow to the top of the pole, kind of sounds like Dr. Seuss, is 43 degrees. How tall is the pole? So in general, when we have application problems, okay, it's usually going to be helpful to draw pictures, okay? And my artistic ability is lacking, so you can all marvel at how great this picture is going to look. All right, so then we have a pole that is tilting towards my sun and its shadow, and then we have a triangle that is created. Now they tell us that our shadow is how long? 22 feet, and that the angle of elevation is what? 43. Now they also give us another angle. They say that that angle is what?
8 degrees.
8 degrees, but we need to be careful. Okay, so that's going to be this one here at the bottom. But does that mean that this full angle right here is 8 degrees? No, it's 8 degrees from what? The vertical. So we're going to create basically a vertical there. So if I created a vertical, what type of angle does it have to create with the ground? 90. And then we also know that this part is 8 degrees. So what is that full angle? 98 degrees. And so what are we given here? Like what case are we looking at? Angle, side, angle. So if we wanted to let's say, this be A, this be big B, and then notice that my 22 would then have to be our little c. So under your example for angle, side, angle, we have big A equals 98 degrees, big B equals 43 degrees, and little c equals 22. But again, like we said before, our steps are still going to be the same. Okay? And actually, we don't have to solve for all the things, because really we only just need one thing. What do they ask us for? How tall is the pole? Which is technically going to be our little b, right? So at the end of the day, that's all we need. Okay? So we're going to set up our equation. We have little b over sine of big B. Okay? So what's the other side that we have? Little c. So we're going to have to use our fraction that has the little c in it. But what does that mean that we are also going to need to find? Big C. But how do I find that if I know what my other two are? Subtract it from 180. So we have 180 degrees minus 98 degrees minus 43 degrees, which gives us what? 39? Okay. And then again, we're just plugging and chugging. So big B is 43, little c is 22, big C is 39, and again, we're going to solve the same way by multiplying by that sign that's on the bottom, and then plugging into our calculator, and what do we get?
23.84
23.5